In the second unit, we go into detail, the gory details of projections and coordinate systems. And the reason we do this is because in your future, if you do GIS, someday there will be a day that you get eaten alive by a projection problem. Really upset a project. And so what we're trying to inculcate here early in your GIS career is a set of practices you can adopt that will help you conquer or prevent even those problems. Here in this presentation, I'm going to sort of walk through the logic of how you might approach this. I don't want to give away the cookie store. I will show you a couple things about the data, but I'm going to return to this basic logic here. I'm going to begin an ARC catalog or catalog view. I'm going to open up a project, a new project without a template. I'm not going to open a map. I'm not going to do this inside of a map. I'm going to do it in catalog. That solves and prevents a lot of problems. I'm going to solve the problems that I can in catalog, and then I'm going to move on if I need to and inspect the metadata of files in a browser or whatever you want to open an XML file in. And then I'm going to talk about a process for sort of systematically guessing when that is absolutely necessary. And I want to remind you that in the presentation, and here I'm looking at lecture 2 from georeferencing and digitizing and coordinate reference systems, this is a helpful little key. So there are going to be times when we look, for example, at the metadata of files in what follows, when I look at the numbers and I try to sort out what I'm looking at. So a key difference is between geographic coordinate systems, so things that are referencing things using latitude and longitude, usually. We have 2 of those that we tend to work with, and those would be WGS84. Generally, those are data that come to us from the Global Positioning System or some online source like Google Maps. We also have NAD83. That tends to be data that comes from public sources like the federal government. Tended to do everything in NAD83, and state and local governments as well. Then we also have projections that we tend to use a lot. State plane for Maryland in this class, and UTM Zone 18N, which is the zone for our part of the East Coast in Maryland. State plane is available to us in multiple forms. You can get it in NAD27 or NAD83, so built on 2 slightly different models of the shape and size of the Earth, and those have slightly different coordinates. We also have NAD83 state plane in meters, and you can see the numbers aren't all the same. You can see how they refer to it varies. And then we also have UTM. Now UTM is available in NAD83, NAD27, and I don't have it here, but it's also available in WGS84. So bear in mind, there are different ways that those numbers that you see in metadata may appear, and thinking about that can really save you some time. So with that, I'm going to switch to ARC and show you a few things. Here I'm going to get the data from the same source you do. These are the data from the Google Drive where you are downloading the data. So what I'm doing is just copying the data from that folder to my own version, which I'm calling Lab 2 Sleuthing. And there they are. And then, just to make sure I don't mess them up, I'm just going to remove this directory. So I didn't show you this step, but what I did was I created this untitled project without a template. And the first thing I did was I went up to View, opened up Catalog View, and made my own copy of the data for the projection sleuthing exercise. Now what I recommend doing is one file at a time, and I think it's probably a good idea to do this with a sheet of paper. Take notes as you do it, or somehow take notes, paper or virtual. And I'm just going to look at the properties of these files. I'm going to right click and look at the spatial reference. For example, block groups says it has an unknown coordinate system. So I'm sort of starting from scratch with block groups. Now if I look at the geography for block groups, I can see it, and it looks like it kind of has an arc. Like it might be that it should be defined as a projection of some sort. I have to figure out which one. And so I can try different projections until that file lines up instead of in the Gulf of Guinea, where it should on the east coast of the United States. But my starting point for block groups will be I don't have any kind of defined coordinate system, and so I just need to figure out what that might be. Now buildings, I can do the same thing. Look at the properties of buildings. It seems to have an unknown coordinate reference system as well. Congressional district has NAD83 as its coordinate reference system, but I don't see it in the preview, in the geography preview. Now that tells me something's wrong with this file. It's telling me that it does have a defined coordinate system. It's not unknown, but the fact that the geography doesn't appear makes me think, okay, so there's something wrong with the projection. Can I see the table? Are there actual features associated with this file? And indeed there are. There are 8 different polygons that I should be seeing on that map, and I don't see them. This is as good a time as any to cut to the representation or a different version of these files. In the Lab 3 Sleuthing folder here now I'm looking at the Windows File Explorer, the native tool for exploring data in the Windows environment, not in ArcCatalog. I don't do this much when I'm working in GIS, but sometimes it's helpful to look at the actual structure of the files a little bit deeper. And here you'll see, for example, block groups. I have all of these files associated with block groups. These 4 are temporary files, these lock files. So they only show up because I have that file open in ArcCatalog right now. And so these are the actual files. If I turned off Arc, I would see these files in the directory structure. I have the 3 files that absolutely must be present for me to be able to see it as a shapefile, and those are the DBF, the SHP, and the SHX. Those are the 3 essential files. The DBF file is the database file. That's the attribute table of this file. Now if I compare block groups to congressional districts also has this file called PRJ. I don't see that with block groups. But if I open that with Notepad, I can take a look at what that file says. It's telling me just a code that is basically what that PRJ file is. It is the definition of the projection for this file. So when I run the define projection tool, it creates this file based on what I tell it. And what somebody told it was define the projection as NAD83. So you see this is Geographic Coordinate System, North American Datum, 1983, and that's it. And there's some other codes here telling it what the spheroid associated with the NAD83 datum is, semi-major, semi-minor axis, inverse flattening, those sorts of things. Now, if I were using a different projection, this code would look different. But what I've determined already by looking at congressional districts is I don't think this code is right, so I'm just going to delete this file. And next time I look at the projection properties for this file in Arc, it should say unknown. If it doesn't, if I turn off Arc and open it up again, it will. So now, for all intents and purposes, congressional districts is unknown. So it helps to look at the directory information, just to see what you have for each of the files if you're a little mystified, a little stumped. Now some of these files, if you continue, you'll see that they do have some projection information, but most of them say unknown coordinate system. So you can scroll through and take a look at that. If they all say unknown, chances are when you look at the geography for any of these files, they won't be in the right place. That doesn't mean you can't learn something about the geography. So for example, here Maryland Roads looks pretty flat across the top. It doesn't arc. And so from the geography, I'm going to guess that this is a geographic coordinate system, because in geographic coordinate systems, the lines of parallel are flat. They're parallel to each other. If I compare that, for example, to block groups, let's look at block groups. You see it's slightly more arched, slightly. Not dramatically, but when you get used to seeing these different shapes, let's go back to roads real quick and you can kind of convince yourself that the angles look different. So I'm guessing roads is a geographic coordinate system and ultimately block groups is a projected coordinate system. Don't necessarily trust me on that. So what you should do is go through all of these, make a note of what they appear to be, and many of them will be undefined. Some of them will have other information. So if you get a good guess, so for example with roads, I'm thinking that's either going to be NAD83 or WGS84 because I think that's a geographic coordinate system, so I might just go ahead and try NAD83, run the define projection tool, because right now the projection is undefined, and if I run the define projection tool, and after it runs, sort of click somewhere else and click back on roads and look at the geography and say, is it where it should be? If it's right there on the East Coast where it should be, then I'm like, that's good. I figured it out. Once you have a coordinate reference system assigned to the file, you can then project it into different coordinate reference system if you need to in order to make it align with another file in the map. But my suggestion in this exercise is do this one file at a time in catalog view. I haven't opened a map, right? This is all catalog view. See if you can figure out the files on their own terms in catalog view. Now the next thing you can do if you're looking for clues is each of these files has what's called an XML file attached to it. That is an extensible markup language. This is basically a file that will open up by default in my computer anyway in Chrome. So if I open this file, it should open up in my browser. This is data about the data. This is a bunch of information about this file. And often you'll see, and in this case up here at the top, information about a coordinate reference system. So here I can see, and it repeats itself a few times, it looks like things that are leading me to believe the coordinate reference system for this file is the UTM 18N projection using the North American datum of 1983. That's what I would be inclined to define this projection as. When you are looking at the data here, if you have unknown coordinate reference systems, see what you can ascertain from the metadata, from the XML file. You might not find it up front under lineage. You can search the document for the lineage, and that'll show you different steps along the way, perhaps, that when this file has undergone changes. You may see today's date on there, meaning the lineage is including things that you've attempted to do with this file. And so if you want to start back from scratch, you can always do that and get the same version of the file that you're looking at right now. Another clue sometimes, if you can't find a lineage, is to look at these numbers right here. And again, take a look at our presentation and compare the numbers that you see in that information, which is showing us the bounding box for the file, meaning the easternmost, westernmost, northernmost, southernmost points in the shapefile, in the native coordinates of that projection. So in this case, these would be in meters, and that would be consistent with NAD 83 UTM Zone 18 because it is measured in meters. So these are both clues that you can find in the metadata. You might find some other spatial reference. Now you might find things that don't work, but this is often the best place to start with an unknown reference system. And then you just drag that file in and attempt to define the coordinate system. Now once you've done that and it aligns where it should be on the surface of the Earth, then you can probably with confidence open up a map. And so for this assignment I would say map number 1. Once I've figured out what I think these files should be in ArcView, or in catalog view, I'll open up a map. I'll insert a map and I'll drag, in this case, UMBC points and buildings into that map one at a time. I'd start with the one I'm most confident about and see if they align in the map, and then bingo, that's solved. So then I would insert another map and do the same thing with the block groups, congressional districts, and roads. So that's my basic approach. Once the obvious things fail, so for example, you'll find with block groups in particular, that, I'll tell you right now, has an exotic coordinate system. If you start with NAD 83 and then try WGS, so try geographic coordinate systems first when you're guessing about files, you probably are going to be in good shape. So for example, if I were guessing about this file, I would try NAD 83 because it looks like it's horizontal. If NAD 83 doesn't work, if it doesn't align correctly, then I would try WGS 84. At that point, I might try NAD 27 and see after each attempt. So just put roads in this top box, change the coordinate system, hit run, select somewhere else, click on roads, see what it looks like. If it looks right, great. If not, try another one. Then the order in which I would try things would be state plane based on NAD 83 in US feet, and then state plane based on NAD 83 in meters, and then state plane based on NAD 27 in feet, and just sort of cycle through similar projections and see if one works. Once they do, insert a new map, see if these various things that you need for that map in the assignment align, and then you're done. Just make a note of what the ultimate reference system is for each of the maps and for the files that you put into. And that, in a nutshell, is how you're going to survive the projection sleuthing portion of this lab.